Hello, dear students. Welcome to the other lecture on the differential equation. As you might have, you are aware about those legendary differential equations, and we have already talked about that. This legendre, the recurrence relation is related to that this legendre polynomial, and now the next topic, today's topic is that is basically the orthogonality condition for this legendre polynomial. So. As you already know that the form of the Legendre polynomial or differential equation will be some 1 minus x square y double dash minus 2x y double dash plus L into L plus 1 whole of y equal to 0, right? And y is the function of x here. And if we say that, where basically, if you remember that, or if you have attended the previous lecture on this Legendre differential equation, you know that we define some generating function for this differential equation, and from these generating function we are basically getting different kinds of those recurrence relation by differentiating with respect to xrt or by combining those recurrence relation to get some new recurrence relation. So as we have some 4 or 5 or 6 recurrence relation what we have discussed in previous this video, and if we assume that p of x basically satisfies this if some function satisfies this Legendre differential equation, right? So we define that p of x by, so we can say that if p of x satisfies this, we can say that then p double dash of x minus 2x x dash. Right? So because when since we have some function p of x which satisfies this which basically the you can define that some function which corresponds to this Legendre differential equation, then that can be the solution for this Legendre differential equation, right? And that function will defined by p of x, so it should satisfy this, right? Now we know that if you remember that when we discussed those self-adjoint equations, so this is self-adjoint, right? So the condition for the self-adjointness is that p0 dash of x should be equal to p1 of x. So this is what we have discussed in one of the videos that I already uploaded. So you can check that the one example or 2 or 3 examples on this self-adjoint form of the differential equation, right? So we can rewrite this equation as this will be equal to d by dx of. Right? तो इसको मैं ऐसे भी लिख सकता हूँ because when you differentiate this one, so you'll get that differentiate the second p of x, so it will be p double dash of x 1 minus x square will be as it is, and the second term should be, because when you differentiate this 1 minus x square it will be minus 2x then p dash of x. So that means instead of these two terms I can write d by dx. So that means this will be in the self-adjoint form, or you can say that the coefficient which is related to which is multiplied to the this y double dash, so that should be equal to this one, but the derivative of that, because here if you take the 1 minus x square is 1, that's p0 of x, and that minus 2x, so that's equal to p of x, right? So that means p0 dash of x will be equal to p of x, right? So while this condition, जहाँ पे ये condition satisfy होगी, that p0 dash, the derivative of that coefficient which is multiplied to this double derivative, that should be equal to the derivative or the coefficient which is the factor which is multiplied to the first derivative. So that is p0 dash of x equal to p of x. So when this condition is satisfied, then such kind of differential equation are called a self-adjoint equation. We have already discussed that, and we can. That's why I told you that this is basically a self-adjoint equation. And now, if we have, now instead of that, if we have two functions, so if we define, because we need to prove the condition of orthogonality. So that means we need to construct two functions which are basically orthogonal to each other, right? So let us write now one function we are defining by. So we define that one function by. Let us define one function by this one. I can write this as d by dx of. We define one function Pn of x, and similarly we write one more function that's Pm of x. That's also, so we need to prove that these two functions are orthogonal to each other, right? So first function we define Pn of x. So for such function we can, it should satisfy this equation, this differential equation. So similarly I can write for some Pm of x. So this is for Pn of x. And similarly I can write one more function for Pm of x. Okay, now we have two functions, two differential equations. One corresponds to Pn of x and second corresponds to Pm of x. Right? Now we can do one thing. So let us label this equation second, and, and this is our equation first. Okay. So what I will do here, I will multiply equation first by Pm of x and then multiply equation second by Pn of x in order to get Pn and Pm both, right? Because in order to, so you know the condition for orthogonality, right? So in order to get that, so you need to multiply the reverse coefficient. So for this Pn of x, you need to multiply Pm of x, and similarly to this Pm of x, you need to multiply by Pn of x, right? So we can write here multiply first by. Okay. So we can write them and then integrate it. And we need to integrate it and then integrate it. Right? तो उसके बाद हमें integrate करना है, but we need to choose the limiters because you know that. So let's have a quick look on this, because if you check this differential equation, so it doesn't have a solution at x equal to 1 or x equal to -1, right? So that means जो हमारा origin है, so we have this, so this is +1 and this is -1 and this is 0, right? तो जो point है यहाँ पे at point A, so the solution, we don't have solution at this point, right? Because at x equal to +1, so this coefficient is this term will vanish, and so that means we should have solution. It will be convergent. It can have solution between the limits from -1 to +1. So even it can have solution at x equal to 0 also. Because if you put x equal to 0, I will get that p double dash of x here, right? Only matters what should be the first derivative, but this should be non-zero, right? So that means we have solution here. So इस region में हमारा solution है, because at x equal to 1 and x equal to -1, so we don't have the solution. It gets divergent, right? So that means we can choose the limit from -1 to +1 here, right? So that's why I can write here that integrate between -1 to +1. तो इसको मुझे इंटीग्रेट करना है, तो फर्स्ट यू मल्टीप्लाई दिस इक्वेशन. तो इफ यू चेक दिस इक्वेशन, तो यहाँ पे 1 minus x square है. I need to multiply here Pm of x and then integrate, right? Similarly for second equation also, right? So equation first will be then, so you can write that equal to 0, right? So these will be the two equations. After multiplying equation first by Pm of x and to equation second multiply by Pn of x and then integrate both equations between limits from -1 to +1. As I already told you why we are choosing limit -1 to +1, right? Because we can have solution in between -1 to +1, right? We can, okay? So after that, so let us first evaluate first term, right? So let us evaluate this one. So if I evaluate this equation, so we have two equations here. So first equation, let us evaluate first equation. So when I evaluate this term, let us choose this one. So ये जो term मेरी है, so this term, this whole term, let's evaluate this and integrate between limits -1 to +1, right? So ये जो equation है, so we can have that -1 to +1. Sorry, I forgot one thing here. So because we can have here d of x. So sorry. So this will be d of x, right? And similarly for this one, we can have plus one. Okay, so you write this way. Equal to 0. And similarly for this one, it will be -1 to +1, right? And okay. Now we need to evaluate this first term. So first term will be equal to this one. Okay, so this will be equal to. Okay. Now, because we have this Pm of x, P dash of x, now you should choose the limit now. Because we need to put that limit x equal to +1 and -1. So when I give the limit here, it will be equal to. जी सर सर मुझे कुछ अपलोड वीडियो करने होते हैं यूट्यूब पे सर एग्जाम शुरू यस सर Okay, so you can write this as, so because यहाँ पे जब मैं लिमिट दूंगा x equal to +1 and -1, so this term will be 0, right? Because if you take the x to be 1 minus 1, so this whole term will be 0. So only this term will survive. So I can have that -1 to +1. That's this will be equal to. Okay, because this was already p and dash of x, so this is what I wrote here, right? So this term remains. And similarly, अगर मैं ये वाली term, तो ये कहाँ से आ रही है? It is coming from this term. When I evaluate the first term. Similarly, जब मैं ये term evaluate करूँगा, so I need to evaluate this term, right? So from this equation, right? And similarly, I can write that -1 to +1. right? Because जब मैं इसको integrate करूँगा, similarly following the same procedure, if I integrate it by parts, so I will get again same term. यहाँ पे pm of x के बदले मुझे pn of x आएगा, यहाँ पे आएगा pm dash of x. But again when I give the limit from -1 to +1, so this term will be 0 here. And now we have second term. So instead of this pm dash of x, we should have pn dash of x, then 1 minus x square pm dash of x d of x, right? So this is equal to, because they will commute, so you can rewrite this as pn dash of x, pm dash of x, right? 1 minus x square this term, right? Okay. Now these two terms are, so that means instead of this and this term, I will write those solved terms, right? So then I can do one thing, I can subtract these two terms. Right? So if I subtract them, or you can first let's rewrite them. Huh? So these two equations will be, okay. So you can write this as, that's equal to 0, right? तो ये because, तो इस टर्म के बदले जो ये टर्म है, so why is that term? Okay. तो इस टर्म के बदले मैंने लिखा 1 minus x minus 1 minus x square, that this term, okay? Right. So this term, that minus pm dash of x, pm dash of x, और जो already term थी, that was n into n plus 1, from -1 to +1, pm of x d of x equal to 0. And similarly for the second equation, so that's basically this one. तो इस टर्म के बदले मैंने भी similarly I wrote this term plus n into n plus 1, pm of x d of x, that's equal to 0, right? So now because if we have a look on this, so on these two equations, तो अगर हम ये दो equations देखेंगे, so this term will be same because we have this minus 1 minus x square, same thing, right? If I subtract them, right? So I can do one thing. If I subtract, so you need to subtract these two equations, so we can write that. So this term will cancel, so we can have n into n plus 1. That's equal to 0. Okay? Or you can rewrite this as, because if you solve this, so this will be n into n plus 1. So this will be equal to n square. So this will be, तो इसको मैं ऐसे भी लिख सकता हूँ ना, because this will be n square plus n minus m square minus n. You can take that n square minus m square and okay, you write plus here. Okay, let me. So there's a mistake now. Okay, so okay, you write this as. So this will be n square plus n minus m, right? तो इसको मैं लिख सकता हूँ, that is n So we have two equations. So first equation was, actually there's some problems, so let me rewrite them. N into n plus 1. Okay. So first is that's n square minus m square plus n minus m. इसको मैं ऐसे भी लिख सकता हूँ because you can write that n square minus m square plus n minus m, or this will be equal to, you can write that n minus m you take on. So inside will be n plus m plus n, because it's clear. So by writing that, this will be n square plus n minus m square minus m. Then you write that n square minus m square plus that n minus m. Then you take now, because this you can write that a square minus b square, a plus b to a minus b. And then you take that a minus b common, that's n minus m common. So inside will be n plus m plus 1. So instead of this term, I can write this whole term, right? So that means I can rewrite this as, so instead of इस term के बदले में लिख सकता हूँ, that is n minus m into, and inside will be that's minus 1 to plus 1. That's the concept, right? Now there are two cases now. If we consider for n not equal to m, because either this term will be equal to 0 or that term will be equal to 0. So if I put that n is not equal to m, right? So I can write this as for, so in that case जो हमारी इक्वेशन ये है, जब n m के बराबर नहीं होगा, so that means this term is not equal to 0. So then this can be equal to 0, because I am saying that when n is not equal to m, so that means this term, so n minus m into this term is not equal to 0, right? So n is not equal to m. So in that case, either this is equal to 0 or that is equal to 0, right? So that means this term will be 0 in that case, right? So we can write then, so that basically indicated that these two functions, in the case of that Legendre polynomial, are orthogonal functions, right? Because the product of these two functions comes out to be equal to 0, right? So that means this is basically the condition for orthogonality. Okay. Now second case is, तो पहला हमने लिया था अगर n, if n is not equal to m, or if we put that n is equal to m, जब n m के बराबर होगा, so that means ये जो मेरी टर्म है, so this term is equal to 0, then this will not be equal to 0, right? So in that case I can say that for n equal to m, so we can write that then minus 1 to plus 1, right? So in that case, let us use now from the property of that. So from that generating function, let's rewrite that. So where we know that the generating function corresponding to this Legendre polynomial, that's 1 minus 2x3, right? Or I can write this as, now if you integrate this equation now, so you can rewrite this as, so you can write that, uh, you can rewrite this as 1 minus 2x3, okay? This is equal to summation So this is how you define the generating function. Okay. Now if you integrate this equation and multiply by some fact, so you can rewrite now. So इसको मैं लिख सकता हूँ 1 minus 2x t. Right? I basically multiply it by one more function so that I can define by right. So this is simply I'm basically multiplying two generating functions. So one is corresponds to m equal to 0 to infinity pn of x and second is pm of x. So that's why यहाँ पे मैंने लिखा 1 minus 2xt plus. So this is basically the product of two generating functions. So one corresponds to that pn of x and another for pm of x. Right? Okay, right. So when you take their product, so this you can write as okay, because let's have a look on this because so this will be simply that minus 1 by 2 minus that's minus 1 and this will be because we have two summations, one goes from one is over that n and another is over m. So it is mn 0 to infinity pn of x pm of x and t raised for n plus m. So this is what I wrote here now. Okay, now let's integrate this. Let's integrate it between again limits from minus 1 to plus 1. So it's already clear that we can have solution between those two regions. Or you can have solution outside that domain also. X greater than 1 or x less than minus 1. Right? So if you go outside that, so you can have solution. But let's choose that region from minus 1 to plus 1. So that's why we integrate this equation from between the limits from minus 1 to plus 1. Okay? So you can write this as okay. Now, if you integrate, so this is dx by x, so its integration will be so let us evaluate this integral first. तो पहले इस integral को evaluate करेंगे, then we can put it that is equal to this thing. So this integral will be equal to, so we can write that we can write this as so you can make one substitution here. You can put that 1 minus 2x t plus t square. So it is equal to some y value, or you can write that minus 2t dx will be equal to t, right? Okay, because you just put this value equal to t, and then dx will be equal to that's minus 1 by 2t. Okay. So what about the limits? So limit is क्या रहेंगे? Because when you put that our x equal to 1, so अगर मैं for x equal to 1, for x equal to 1 you can write that जो हमारा y है ये क्या बनेगा? It is 1 minus 2t क्या बनेगा 1 minus t का whole square because this 1 minus 2t x equal to 1 and x equal to minus 1 जो हमारा y होगा that will be 1 plus t का whole square right because x equal to minus 1 it will be 1 plus 2t plus t square right so that will be 1 plus t का whole square. Now the limits will go from 1 plus t का whole square to 1 minus t का whole square and this integral will be equal to so we can rewrite this as limit is from t whole square into and what is dx that is minus 1 by 2y 2t into dy upon okay so that's because dx is equal to that's minus 1 by 2t dy and divided by y right so this will be equal to we can write this as okay because when you give the limits so it will be as it is so it will be that log of m raised per n it will be a log m or this will be equal to this will be equal to okay because you can take that 2 common so that will cancel with this 2 and this minus will multiply so you can add this first term then second term this और this will be equal to इसको मैं देख सकता हूँ 1 by t log of 1 plus t upon right इसको मैं ऐसे भी लिख सकता हूँ or you can do one thing you can elaborate this term huh? so better is to write this way so you can so there are many ways to how to write this so better is to expand this because we have this log of x so you can expand this so log of x you can write this as so this will be equal to 1 by t and inside will be so that is summation n goes from 1 to infinity that is minus 1 raised power n plus 1 e raised power n by n minus n goes from 1 to infinity and that is minus 1 raised power n plus 1 e raised power n upon right so इसको मैं ऐसे भी लिख सकता हूँ that's minus 1 raised power n plus 1 e raised power n because we put the n equal to 1 so you will get first term n equal to 1 here so this will be plus term and then for 2 it will be minus so because you can expand this log of 1 plus x right so इसको ऐसे लिख सकते हैं or you can do one thing you can write that log of m minus n so that's log of m by n then you expand so many ways to do it so you can write that now if you expand that so this will be equal to so you can take that e raised by n by n common right so this will be equal to 1 upon t into so inside will be that is minus 1 raised power n plus 1 plus n okay sorry so there's one mistake so because here यहाँ पे जो टर्म आएगी कौन सी टर्म? Okay, so this is minus 1. Okay, so it should be minus here. Yeah? So it will be minus 1 raised power n, minus t raised power n. Huh? Or you better is to write this way. Let me drop this whole part n plus 1. तो इसको मैं ऐसे लिख सकता हूँ minus t raised power n, right? Or when you take that t raised power n common, so यहाँ पे क्या बनेगा? So it will be equal to minus 1 raised power plus 1, right? Because you take minus into minus, that's plus. So this will be minus 1 raised power n plus 1 plus 1. Okay. Or you can write this as okay. So this will be equal to 1 by t, or you can write that t raised power n minus 1 n plus 1. So this will be equal to t raised power n. Okay, so this will be equal to t raised power n plus 1. Okay. Okay, so you expand that. So this will be equal to 2 into, so that is 1 plus t cube by 3. Huh? So because putting that n equal to 1, so this will be okay, because n equal to 1, so this will be t and t will cancel, n equal to 1, n equal to 2, so that is t raised power 2, it will be t, so it will be again t here, right? And then when you put n equal to 2, so this will be minus here, so minus plus will be cancelled, है ना? क्योंकि पहले जब n का वैल्यू 1 लूंगा मैं यहाँ पे, तो दिस विल बी t रेज पावर 1, तो ये t और ये t कैंसिल हो जाएगा, राइट? एंड इनसाइड क्या रहेगा? माइनस 1 रेज पावर 1 plus 1, so it will be plus 1, so 1 plus 1 will be 2. Okay, let me write one more step that I can put it in some compact form. So putting n equal to 1, so this will be 1 by t into that will be 1 plus 1 t raised power into 1 t raised power 1 by 1, huh? And plus that. Okay, so this will be added, right? Because अगर मैं पहले टर्म यहाँ पे लूँगा, this t and this t will cancel and this 1 plus 1 will be 2. So we'll get here 2 plus, and here it will be minus 1 square, this will be 2, and this will be 2t, 2 into uh, this will be equal to 2t by 2, right? And then so this term will cancel, minus plus will be 0, right? So ये term 0 बन जाएगा, right? And similarly we have higher terms also, right? Okay, because when you put that n equal to 3, so this minus 1 raised power 4, this will be t raised power 4 divided by 4, right? So that means now if you take that 2 common, inside will be 1 plus, because this 2 and 2 will cancel, we have 2, so that 2 we need to divide here, and this will be t I did a mistake, minus 1 raised power 0 minus 1 is 2. So this is, sorry, this is here, sorry, I did a mistake, because when you put n equal to 1, तो यहाँ पे क्या आएगा? It will be plus, and here it will be, okay, let me check, because here I did a mistake, okay, and okay, so we can, okay, let me write these two terms once again. तो पहली जो टर्म होगी यहाँ पे, ओके, तो पहली वाली टर्म, बिकॉज यहाँ पे n1 ले रहे हैं, सो इट इज t1 by n, है? तो पहली वाली जो टर्म है t and t will cancel, it will be 2 here. Now second, when you put n equal to 2, so this will be 3 here. Okay, so this term will be 0, because this will be minus 1 plus 1, so this will be 0 here, right? And ये term survive होगी, because minus 1 is for 4 here. So we can write this way. Minus 1 is for 4, this is t cube divided by 3. Huh? Right. So this will be 2 plus, because ये term minus 1 plus में ये 0 बन जाएगी, and plus this will be 1t and t cancel, so it will be t square by 3. Okay, okay, right. And similarly we have next term क्या बन जाएगी? So next term will be some, it will be some t raised power 5 upon some value here, right? So I cannot, so you can check it yourself by putting that n equal to that 3 4, right? And now if you take that 2 common, so inside will be that's 1 plus, it will be t square by 6 plus t raised power 5 upon some, so it comes out to be 5 factorial. So that means it is 5 into 4 into 3 into 2, right? So you can check that yourself. So plus, so this will be equal to 2 into, so if you check this sequence, so this is, so 6 you can write as, so this will be similar 3 factorial, and this will be 5 factorial. So that means what should be our next term? So that will be t square t raised power 5, and then I cannot get, because it doesn't follow the regular pattern, right? So then in the denominator we should have 7 factorial, right? So and so on, right? So this I can write as twice summation, and start from 0 to infinity, that is t raised power 12 upon, तो इसको मैं ऐसे भी लिख सकता हूँ, because by putting n equal to 0, this is t raised power 0 that divided by 2 into 0 plus 1, so ये term बन जाएगी overall. So outside is 2, so this is this 2, right? And now next, when you put n equal to 1, so ये बन जाएगा t square upon 2 into 1 plus 1, it will be t square by 3, and this 2 is here, right? So this is what it is. So t square, because putting n equal to 1, sorry. Okay, so this is right. So this should be 3 factorial. Okay. So by putting the different values of n, you will get this expression. So इसको मैं generalize कर सकता हूँ by putting n equal to 0, 1, 2, 3. You will get this whole expression. But this is from, तो ये कौन सी term मैंने expand की? So when I solve this term, that minus 1 to plus 1 dx upon 1 minus 2xt plus t square. इसके बदले मेरी वो term है, that is twice summation n starts from 0 to infinity 2n divided by that 2n t raised power 2n divided by 2n plus 1, right? तो वो term इसके बदले होगी, इसके बराबर होगी, right? So that means I can write them instead of this term. Okay, so I can write that summation 2 into, so that's minus 1 to plus 1. Okay, or you can rewrite this as, because now you can do one thing. So there is some, so actually I forgot one thing. So just check that. So what I have to write here. Okay, so which is that term? So this term, right? I basically forgot here this term. What? So that is basically t raised for n plus m, right? So यहाँ पे भी check कर सकते t raised for n plus m, right? So that means, तो यहाँ पे मुझे और एक extra term लिखनी है. So that is, okay. Now you can equate the coefficients of t raised power, that for n equal to m, अगर मैं for n equal to m, so this will be equal to, right? Equal to, that's twice summation I can write this as, so this will be equal from -1 to +1. Right? So this is the condition for this normalization, because when n equal to m, so you can hold this, so its value will be 2 divided by 2n plus 1. अगर n m के बराबर नहीं होगा, then this term will be 0, right? So you can have this orthogonality as well as the normalization condition for this Legendre that polynomial, right? So this was all about this Legendre differential equation. So hopefully you might have get everything what I delivered in this video. So hopefully if there is some problem or you have some confusion at some point during this lecture, so you can write me in the comment section. So try to if you want to if you want something to be explained, so I can you just write me in the this comment section. So I will try to respond it as soon as possible. Thank you very much.